Hi guys and girls on YouTube, and welcome to my channel. Now, for everybody who's been watching my channel over the last couple of weeks, you'll notice I posted a couple of videos demonstrating how easy it is to find a short circuit on the circuit board with a milliohm meter. Now, I've been inundated with requests for the schematic diagram for this meter. Now, I didn't actually design this. I made it from a magazine. All I've done is modify it to suit my requirement. And it's taken me quite a long time to actually find the schematic because I've got thousands and thousands of magazines spread over different places. So for everybody who's been waiting very patiently, just stick with me and watch this video. So before we move on to the meter, let's just have a quick chat first. Right, so this is my homemade milliohm meter. Now, you could probably build this. There's not a lot to it. You could probably build it for about £20. If you don't want to build one, you could just buy one. If you've plenty of money, you could just buy one. Here I've got a radio spares one. So let's just tip it out. Press the button, that brings it on. As you can see, we've got 4 terminals on the front. Exactly the same as mine. Right, so this particular one, it's a radio spares component one. That's the one there. It comes in a nice fancy carrying case. This will set you back £373.12 plus VAT, which is including the VAT if you're not VAT registered like me, which is £447.74. Right, so that's it in its carrying case. If you've got even more money to spend, you could actually buy, better than a milliohm meter, a micro-ohm meter. But we're not going to concern ourselves with very expensive test equipment, because this one you can build yourself for next to nothing. Right, so I've got the screws undone on the case. First, let's take the lid off and see how remarkably simple it is. As you can see, there's next to nothing in it. Now, all this side, this is the power supply. So the actual milliohm meter only consists of 4 semiconductors. So for everybody who's wondering why we've got 4 test sockets and only 2 clips, and if you look, these wires are actually in parallel. Well, these are called Kelvin clips, and this is the most important part of a milliohm meter. The reason we've got 2 wires is they cancel out the resistance, so we get an absolute zero. So I'll just give you a quick demonstration. We'll just move to this Fluke multimeter, and what I'll do is I'll put it on ohms, and then I'll short, when you get it out of the light, I'll short the test connectors together. And if you look there, we've got 0.3 or 300 milliohms. Now, what we're reading there is the resistance of these test clips, the resistance of the wire. But with the Kelvin clips, because we've got 2 in parallel on this side and 2 in parallel on that side, it actually cancels out the resistance of the lead. Now, the most important thing with these, see, a quick example, we've got 2 connectors there, but you've got to take a measurement from the middle of them 2 connectors. So if we draw a point there and another point there, this is the place where we're taking the reading from, and that will give you that center point of these 2 connectors. That gives you an absolute zero. So whereas on the Fluke we're measuring the resistance of the leads, if we turn the millivolt meter on with the connection shorted, it should read 0. And that's it. That's reading absolute 0. And that's why it's most important to have these Kelvin clips. Now, of course, you could make a pair yourself with a multimeter probes, but what you'd have to do is you'd have to solder them together right at the very end. And if you don't do that, if you was to put the lead, say, here, then you get a false reading, because you'd actually be measuring, you'd also have from there to there, that will measure a certain resistance. In this case, it's probably micro-ohms. But to make an accurate measurement, both them tips have got to be absolutely joined at the very edges. Right, so here's the schematic of the milliohm meter. As you can see, there's next to nothing to it. Now here we've got a digital multimeter. Well, I didn't want a digital multimeter because that ties up your meter. As you can see, in this design, it was designed to plug into a digital meter. Well, I didn't want that. I wanted an independent meter, so I'm not tying up another meter. So what I did is I bought one of these little panel meters. It's not this one, it's a different one to this. But the most important thing is you've got a resolution of 0 to 200 millivolts. Now, I think with these panel meters, most of them come with that resolution anyway, 200 millivolts, and you just put shunts across them to suit your needs. So that's the first thing I deviated on here. Now, also, you'll notice it's got, on this design, it's fed from AA batteries. Well, this thing actually consumes alone 100 milliamps. Which is quite a lot of current to be drawing from batteries, especially if you leave this on for a long period of time. So what I wanted is a mains powered one. Now there's two slight problems. Because you're using a digital panel meter, you can't connect the ground of that to the ground of this. So if you're going to be using a little panel meter, as I've done, you need two separate power supplies. You need one to feed the millivolt meter circuit and one to feed the digital panel meter. So as you can see here, I've got a little mains transformer with two independent 6-volt secondaries feeding a bridge rectifier and two linear regulators. Now one of these regulators is feeding the panel meter on the front, and the other regulator is feeding the milliohm meter part. So that's what all I've deviated from the magazine is I've actually mains powered it, because also if your batteries go down you could get false readings. So by powering mains, you've got a thing you can run all the time. You don't need to worry about batteries, you don't need to worry about false readings because it's always on power. Let's have a look. That's the digital panel meter at the back. As I said, this is just a little thing I bought in, probably cost £5 or £6, I can't remember now. And the 4 test sockets on the front. So as you can see, really simple to make. I mean, you could use it with a multimeter. You don't need a separate display on the front, but I just found it a lot better to be not tying up a multimeter and to have a big red LED display. So now let me show you where the schematic is. Please don't ask me to post you the schematic on. I just don't have time to scan it and send it to everybody, but I'll show you how to find it, I'll show you where it's come from, and you can look it up yourself, nice and simple. Right, so here's the magazine. Just so we don't lose the page, let's just put something into there. So as you can see, it's television and consumer electronics. It's July 2005, and there it is on the front page. Turn it over and it's page 534, and I'll show you where you can get a copy of this magazine from. And you can get this on the internet and just download the you can just print these out yourself. Right, so that's the magazine. Go onto the internet and type in World Radio History Television Magazine, which has come up there. Click on that. Click on the one that says Practical Television. And then if we move down here, we want July 2005. which is that one there. And there we go. That's the one. So now you can look that up yourself. You can read it on the internet, or you can just go to the pages you want and just print it off. Right, so to buy a set of these Kelvin clip leads, which it's a lot easier and a lot better to just buy a pair than try and make your own. Go on to AliExpress on the internet, type in Kelvin clips, and that is the set of Kelvin clips. Just less than £10 for a set. Right, well, the only other thing to mention now, because we're getting towards the end of the video, is the components. So you can see here, we've got a chip, a TLE 2425, and an op-amp TL071. I would strongly recommend that you do not buy these two chips on AliExpress, because you're likely to get fakes. You can get both of these from RS Components in Leeds. I think that one cost about £2 or £3. They're not expensive, but if you buy on eBay or if you buy on AliExpress, you're likely to get fakes, and you might not get this project up and running at all. So alright then, guys and girls, many thanks for watching my video. Like I say, I'm very sorry for everybody who kept asking for this schematic, but it's taken me a long time to find this magazine. So alright, guys and girls, many thanks for watching my video, and I'll catch you in the next one. Goodbye for now.